yesterday, which would be example 4, but I don't think it'll take us as long because I don't have to do any of the pre-skill stuff. So let's go take a look at example 4 if I can scroll a little, just a touch. There we go. All right, example 4. I have got it right in my face. This is the last one of going to the infinities that I'm going to do. Yes, somewhere up there. That's the best I can tell you. It should be. No, you dig around a little bit. I don't know. It might be on top there. So. Oh, there.
You did it last year.
This is it. Okay, guys. Here we go. Sorry. I had to get somebody something if they listened to the recording, and then Mandy decided to be off task. All right.
That was them.
That was them. All right, so the last one where we're approaching an infinity. Okay, those are super easy to spot. Remember, we can't use infinity as a number. It's technically illegal. Most of the time, but not always, if you treat it as a number, you'll get the right answer. But I said not always, so this always works. So this is my issue from yesterday, right? And then I bracket this off. That's actually not part of the formal notation, but I just, like I told you yesterday, I just kind of let that limit leave my brain for a little bit, because after I set it up, I really just need to do the antiderivative. When it's not a one-stepper, I like to do it over here on the side. So what skill is it that'll be my anti-derivation technique for this? This is a by parts. Yep, I've got a line, right, or a polynomial, and an exponential function. I'm going to do that off on the side. So my u is my algebra. It's not a hard by parts. I do think there's one on your worksheet where there's a natural log in there. Right? Maybe? I don't remember. But here we go. There is my dv, and then my du would be a -1. And then my antiderivative, it's the only function in the world whose derivatives and antiderivatives are themselves, which is kind of nice, are e to the x and e to the negative x. Then I'm even going to stay out of there right now, and I'm going to say it'd be 1 minus x times a negative e to the negative x. There's my uv minus, and then I'll be multiplying both of these, so that's a positive. So I'm just going to do a positive e to the negative x. I always have to watch my signs in there. Right, there would have been 3 negatives, so I'm good. I'll anti-derivate this guy again. By the way, I think I'm going to change. I'm going to distribute the negative in on that just so it's not so messy. So I'm going to make it x minus 1. You don't have to, but I like it better. And then it would be a plus e to the negative x. Then you have to decide what you want to do with that, because if you want to work with it, go ahead. If you want to distribute this in, go ahead. Sometimes stuff cancels off. Let's see if it would. Yeah, I think I will distribute if I... Oh, I would distribute that. You don't have to. Again, you can work, once it's anti-derivated, it can be in any form. But did you see what I was saying? I said, I'm going to see if that would be nice. Why would that be nice? The e to the negative x is going to go. Yeah, so I'd have x, e to the negative x, minus it, plus it. So I only actually have to work with that if I distributed it. Or you could have factored it out, or whatever, or left it, it doesn't matter. That is, though, my antiderivative. So I'm going to go back over here. All of that cleaned up to be e to the negative x. It's my limit. B approaching infinity. Now my limits go out here, 1 to b. What did I tell you is super wise to do when you have negative exponents in these types of problems? Put them in the denominator so you can see when things are going to 0. It's hard to tell what's going to 0 when you have those negative exponents. So I go like that. Next up, we put the b's in. If you were absent yesterday and didn't watch the notes, this is going way too fast, but you should be okay. I'm going to take the, limit as b is creeping up onto infinity of this guy minus 1 over e. So then I have to decide what this guy goes to. Oops, I'm going to have to put the b in. This guy actually goes to infinity on the top and infinity on the bottom. Technically, like I said the other day, this is L'Hopital's rule. Think of it as x over e to the x. It'd go to 1 over e to the x and then 0. But it's very safe for you just to assume because we've got such a powerful function on the denominator. So this would converge to negative 1 over e. It means the graph of it falls more under the x-axis than above it on that interval. Does that make sense? Are we good? Again, we're not going to work with the, oh, I do have one more of the infinities. All right, there's one like this on your homework. So this has got infinity in both places. There's 2 ways for you to deal with that. Actually, there's 3. You can pick your favorite number in the world, put it on the top. You don't need to write this down. So you can put any number you want on the top and write it down, and then do plus 7 up to infinity and write it down. You can pick any number along the way to make your split. Does that make sense? Think of when you anti-derivate. Wouldn't the 7 go in first? Correct? Minus this stuff, and then the infinity stuff minus when the 7 goes in. So it doesn't matter what number because it's going to cancel out when you do your fundamental theorem of calculus. So that's one way to do it, is just pick your favorite number. Or you can put just a variable there, and it doesn't really matter because whatever happens at C here, you'll be subtracting it on this side, so it's always going to cancel. The other thing to do, and I think it's wise, is check to see if it's an even function. Because, do you remember what I said happens for even functions yesterday? I said you could just start at 0, and it's symmetrical, so put a what in front of it? 2. Usually, once you figure out if it's an even function, this is way quicker because you're not dealing with 2 pieces. Does that make sense, Owen? So to check if it's an even functions don't mean they have even powers. It means that when you put in, watch, just a little bit of algebra 2 or pre-calc or whatever, I don't teach those, so I don't know where they teach it. But they should have told you that even functions, when you put an x in, it has to be the same result as if when you put in a negative x. And it's really easy to check. Watch when I multiply this way. I get e to the x, correct? And then I get plus, and then I have to add these exponents. So I would have e to the x plus e to the what? Tell me. What do I get when I do e to the x and e to the negative 2x? E to the negative x. On the other side, I get e to the negative x. And then I'd also get plus e to the x. Did it balance out? Are they the exact same function? Yes. So that means it's even, which is nice. Now, if that had been a 2x and that's a 4x, well then for sure, right? Because we have all that even stuff going on. But, yep. So let's go up here and let's just double what we get when we go to the infinity from 0. Sorry. Now I got another person. Nope. We're good. Wow, I'm popular today. Okay, there we go. So, now I have to figure out what antiderivative I'm going to use. Can I look at it? Is it u sub? So close, right? The derivative of the bottom would be 2e to the 2x, though. So not a multiple of the top. Anyone want to blurt what this is? You got it? This is arctan. What's your function that's being squared?
E to the x.
Yes. So this is arctan with your u being e to the x. This would be a squared plus e to the, and its derivative is e to the x, so it doesn't even need anything. This is just 2, I better insert my limit. B is approaching infinity, 0 to b, right? All right, you are correct, Tyler. Good call on the arctan. So we are going to go say that's arctan of what? What's it the arctan of? E to the x. Yeah, it's perfect. We set up for e to the x. I'm still taking the limit. B is heading to infinity, and I still have a 2 out front. All right, so basically what I end up with is arctan e to the infinity, infinity. And then, what were my limits again? 0 to b. And then arctan, not 0, but e to the 0, which is 1. So be a little bit careful with that. I'm doubling because I'm only going to the right of 0. Now again, you got to know how to evaluate arctan. The tangent of what angle goes to infinity? That's the question. What do you think? What'd you say? Pi over 2. Yeah. The tangent of what angle is 1? Pi fourths. Yep. You should know those basic ones. There won't be any of them, I doubt, we're 3 over 2 or weirdos, but those you should know. And so that looks like it's 2 times pi fourths. And so my answer would be pi halves. And I'm done. So that's the last of the infinity ones. All right? The next kind of improper integral is when you have an asymptote, sometimes called an infinite discontinuity, at or on the way. So these are vertical asymptotes on the graph, and what happens is you can't hop them, but you can approach them fast enough so that maybe we get an answer. So we are still going to rewrite them using limits, but we're not approaching infinities now, we're approaching asymptotes. Does that make sense? So what happens here, which number is the issue, 0, 3, or somewhere along the way? 3. This one, 3 or 7, or somewhere along the way? This one, 2 or 5, or somewhere along the way? Somewhere along the way. So I'm going to teach, we're not going to evaluate all these. I'm just going to kind of show you how you would set it up. You go, okay, this is my issue. I need to replace that with my b still. But it's not as b is approaching infinity. It's b approaching 3, correct? But from which direction? The left. Ooh. It's going to be important, so make sure you get that on there. So that's how we would start this one. The evaluating, don't worry about it right now. This guy would be the limit as b approaches, and we go from b up to 7, because b is what we're going to use for our issue, correct? But on this one, I am approaching 3, my issue or my asymptote, but from which direction? The right-hand side, right? I'm going from 3 to 7, so I'm to the right of the asymptote. So be careful with that. What does your gut tell you you're going to have to do when it occurs on the way? Split it. Yeah, you're going to have to split it into 2, where you go from 2 up to b, and then from b up to 5, correct? And your limit on the first one would be approaching 3 from the left, and the other one 3 from the right. Are we good with that? So otherwise, evaluating is the same. So today's is going to go a little faster. This is important though. For the first and second case, if you get the answer 5, the answer is 5. If you get infinity, diverges. On this one, if either one is one of the infinities, or both, it diverges. Okay? So if you get a divergent on either part, it will diverge. Okay, the whole thing. It's kind of nice when it happens on the first part, because you can bail. All right, so here we go. You went to have this kind last year. You might have integrated this from 1 up to 4 last year, so that's the only difference, is that we're going to have to deal with asymptotic behavior on the interval. So we still have our x to the negative 1/3 in there, which is nice. We have to replace the issue with a b. We have to creep up on it, right? B is going to be creeping up on 0. From which direction? What do you think? The right. Yep. From 0 to 1, I'd be to the right of 0. All right, there it is. Now you just anti-derivate as usual. Add 1 to the power. Divide by the power. Still take your limit. You can tell I'm getting sick of writing limits. That's what happens with my limits. Does that happen to yours ever when you guys are doing your homework? Oh, all right, and this goes from 0 to 1. Not 0 to 1. This goes from b to 1. All right, so when the 1 goes in, I get 3 halves, 1 to the 2/3. And then I'd have minus 3 halves of b to the 2/3. B is approaching 0 from the right. What happens to this as b approaches 0 from either direction? What are you going to guess? 0. Yeah. So the answer to this one would be that we converge. To what number? 3/2. All right, next one up. Actually, I have one more after this. This is going faster than I thought. Go ahead and talk me through first step. What do you think I'm going to do? Because I've always told you and I've had you for 2 years. Let's take the 6. Yeah, might as well just get it out of there. I'm going to start my limit. I'm going to have B creep up on some issue. What one's the issue? The 4. Yep. So my B is going to go on the top. 0 is just fine. I'll do my 6 over the square root of 4. 1, thank you. Square root of 4 minus x dx. There it goes. Now, what am I going to be approaching 4 from? Which direction? The left. Yep. 4 from the left. Then I have to go over here. And again, I have to be really good at integrating in the last couple days. What integration technique am I going to use to integrate? I'm just going to go off on the side and do it because I don't like it in my workflow. If that was on, actually that could have been on last year's integration test in AB. And actually the first one. What do you think I'm going to use? U sub. Yeah, right? Who's U? 4 minus x. Some of you do this level of U sub in your head, but I'm the teacher, so I can't. So I'm going to write it down. So I now have 1 over root U. What's du? Negative dx. So I will have a negative correction out front. But otherwise, that's just negative 1 over root U du. Agreed? Are we getting there? What's the antiderivative of 1 over root u? I'm thinking u to the negative 1/2. So it'd be u to the 1/2, right? Times what? 2. And I had the negative. And then last year I would have said, now that you're done using u, get rid of it. And you back sub, correct? That'd been a good u sub review here. So I have the 6. I have my limit. B approaching 4 from the left. My antiderivative ends up being negative 2. So I'm going to go throw that out front if you don't mind. You did see what I just did. I'm throwing that out front. It's u to the 1/2. Or the square root of u. And the square root of u. I'm going from, I lost my limits. What was I integrating from on here? 0 up to b. 0 up to b. Thank you. So I end up with a negative 12 out front. So wait. And then I'll be taking a limit as b zooms up on 4 from the left of it. So you're thinking 3.99999999999. I'll do the square root of 4 minus b minus the square root of 4 minus 0. Top in first, then bottom. So the first one, as this approaches 3.9999999, what does this approach? 0. This guy is a constant, so it doesn't even matter. There's no b in it. So that's a negative 2, correct? So I end up with a negative 12 times a negative 2. 24. Seems like a big number, doesn't it? Watch the graph of it. I have it on Desmos. So I'm going to show you a quick Desmosian here. Yep, I have it right back here. So here's the graph in green. I have the asymptote like in this teal color. When you're integrating from 0 up to the asymptote, you're actually answering the question, how much area is there in here? But do you see how fast that green thing approaches the asymptote? Pretty fast, right? That's why we're getting convergence, but there's this whole big chunk down here. That's why we're getting such a big number. Does the graph kind of jive with our answer? You know, I just wanted you to see why it's so much. This is a lot in here, and then it's not accumulating much up to there. All right, so let's see what's on the next page, or is that the last one? Yep, example 9 is for tomorrow. Actually, it's not for, yes it is. Example 9, it will be tomorrow's. So we are going to go do example 8 and we will quit. What's your issue on this guy? 0's your issue. So how many integrals are you going to need to do? 2. If either one diverges, what are we going to put? Diverge. If they both don't, we'll have to add it up. All right, I don't know the answer to it. So, and this isn't that where you yesterday could just say, oh, it's 1 over p minus 1, it's a half. Remember, you can only do that shortcut when this is a 1 down here and the top is an infinity. So let's go do it. We're going to take a limit. Our issue is at 0, so we're going to go from -1 up to the issue. I'm going to approach it from which direction? And you'll see on this one, actually, it's going to matter. It's going to approach it from the left. Yes, -1 is to the left of 0. And then I'll have my x to the -3 and my dx. And then I'm going to have another issue. Do you think I need another variable, or do you think I can still use b? The answer is it depends on your teacher. So I'm going to be the picky professor today and say don't use b, you've already got it over here. I won't use c because in integration that can be kind of carly. Like, you might mess with your head. I think I'll just use an a. Okay, so I am going to be going from a up to 2 of x to the -3rd dx. What is a approaching? 0 from which direction though? The right, and it's going to matter. It matters sometimes in science, like whether things are positive or negative, right? Do you get why? Like whether you're thinking 0.000001 or -0.0001 can affect signage. So let's go do this. What's the antiderivative of this guy? Boom. What is it? Go ahead, is antiderivative of x to the -3rd. Yes, she's kind of thinking it through and dropping the exponent as she goes. If you don't like to do that yet, again, just add 1 to it, divide by it, and then clean it up. I don't care, but get it out of your workspace. All right, now antiderivated, I'm going from -1 up to b. B is approaching 0 from the left. I'm not even going to worry about the right-hand side unless I get a number for this. Do you know why I'm not going to worry about the right? What did I say? If either one of them diverges, I can quit and say it diverges. I don't know yet because I'm not done, but I always do that with these double ones. I'm hoping to save myself half the time. So I'm going to approach 0 from the left, and I'll have a -1 over 2b squared, and then I'll have a minus, and then a -1/2. So that one's going to be this. Now you got to really think this out. Okay? This is obviously a half. It's really tempting to say this goes to 0. It does if I was approaching infinity or negative infinity, but kind of think of what number you're putting in here. What's right to the left of 0? Negative what? 0.00000000001. Or you might want to think -1 over that. Correct? When I square it, this will become positive with twice as many zeros. Agreed? So I'm basically going to be, or be, having a 1 over a gigantic number. When I multiply by the reciprocal, it'll go on the top. Agreed? Where do you think this is going? It's actually a high-level thought to think about. Where is that going? What do you think? Where do you think it's going? It's not going to 0. Nope. Close. Why negative infinity? Yeah, like if I were to put that b in, like I said, this is approaching 0 from the left, so I'm thinking negative 0.00000 a zillion zeros 1, which is really -1 over a bunch of zeros. But I'm going to square it, so it's just going to add a whole bunch more zeros. So basically what I have here is 1 over a gazillion zeros. When I multiply by a reciprocal, that's going to go up there. So where's it heading? Negative infinity, correct? So this one is going to negative infinity plus a half. Why am I going to quit? It's diverges. It doesn't matter what happens with the other one. All right, it might diverge as well. It might be a 5. It doesn't matter. We can say diverges. Now, I don't know. I didn't make your worksheet. You always know that when you look at the key and it's what? I would never type a key. I'm not that lady. There's no way I'm spending hours on math typing up a key. My keys, because a LaRue key, they look like this. And then I don't go to my computer and type all that crap in there. So I don't know if the author of your worksheet quits when they get one. So you might see on ones like those that they'll do both of them and then say diverge. All right? So you have 25 minutes to wrap up number 9. Which one are you gonna wait on? We're gonna wait on 15 for sure. If you haven't done the infinity ones yet, you might want to do a couple of those. I don't care what order you do it.
Did you say to wait on 14 yesterday?
Let me see what 14. Yes, because I was doing one like it today. If you can do 14.
You can do 14
Yeah.
now? Okay.
I still have the 14.
I tried it.
Yeah. So number 14 yesterday I said to wait on because I hadn't talked about what you do when you have negative infinity and positive infinity. That's 100% though an even function right there. Agreed? So what are you going to go from? You're going to double what you get when you go from 0 to infinity. Agreed? Does it look a little u sub e or arctan? Arctan e. Yep, u would be e to the. You guys got it. Mandy, you're on fire. No, because I did e to the. My answer that I did went from 1 plus e to the 2x, and the top was at e to the x. I did a similar one, but not the exact. It was similar.
I tried to start 15 last night, and I got like 3 steps in, and just.
Yeah, don't do that yet. I'm gonna do that one tomorrow. It's actually a fun one. So tomorrow when you come in, we'll do 15 together. Then I'm gonna put you in groups of 4, and you're gonna do a delta math together on improper intervals. And I think we do FRQs, review tests. That'd be Thursday. Which I might just put on Friday and do start the next week Thursday. That's the only test. In the 14 already?
Well, because we were literally doing it, so I just like kind of.
No.